Hello and welcome everyone. Thanks for joining us today. We're excited to have you on. During today's webcast, we will be doing a quick overview on the three main approaches to continuous software development, followed by a demo of GitLab built-in CI/CD. My name is Agnes and I work on the marketing programs team here at GitLab. I'm joining you from San Jose, California today. If you feel so inclined, please feel free to say hi and tell us where you're joining us from in the chat. Before we get started, I'm going to cover a couple of housekeeping items. First, feel free to ask questions throughout the presentation. You may use the Q&A function at the bottom of your screen for that. We'll have dedicated time for questions after the presentation and demo, but you may go ahead and send in your questions as you think of them, and we'll make sure we get to them at the end. If you're experiencing any technical difficulties, you can use the chat function to get in touch with me, the moderator, for help. Now I'm going to turn it over to Tye Davis, GitLab's Technical Product Marketing Manager, who will kick off the presentation and demo. I see we also have Isaac from our product marketing team on standby to help with the Q&A.
All right, thank you, Agnes. I appreciate it. Just want to confirm with you that you can see the screen. We don't see this bar down here.
Yes, I see the screen. It looks great.
Cool. All right.
Thanks.
My name is Tye Davis. I am with the technical marketing team here at GitLab. Thank you all for joining today. I am going to be spending a good amount of time here and going over GitLab and continuous integration and continuous delivery deployment and how you can go about doing that with GitLab. Obviously, just did a quick introduction. What I'm going to do is I am going to do an overview here with a few slides. I'm not going to spend too much time there. And then I'm going to go into a demo and spend a lot of time inside of GitLab showing you how we go about the process of setting up CI/CD. This is a somewhat technical demo, so it's not going to be all high level. It's going to be talking about how you could set up a couple different things to get your CI/CD going. Then we'll have a Q&A at the end. At the same time, if you have any questions during, there is a couple people from GitLab that may be able to help answer those questions in the chat. As I'm going through the demo, it's going to be hard for me to look at the chat as I'm demoing the tool. So those people from GitLab should be able to answer, and then we'll get to some Q&A at the end. So it wouldn't be a continuous integration or continuous delivery CI/CD presentation without first quoting Martin Fowler, and for good reason, as he is one of the pioneers of defining continuous integration. As he says, a software development practice where members of a team integrate their work frequently. Usually each person integrates at least daily, leading to multiple integrations per day. Each integration is verified by an automated build to detect integrations errors as quickly as possible. And that's the end of his quote. So simply put, continuous integration, it allows developers to merge their changes back to the main branch as often as possible. The developer's changes are then validated by creating a build, running automated tests against that build. And when done correctly, you are able to validate more frequently that an application is not broken as commits are integrated into that main branch. With continuous delivery, this is an augmentation of continuous integration to confirm you're able to release new changes more often in an acceptable way. In addition to automating your testing, the automation of your release process gives you the ability to deploy your application with the click of a button. You're able to release at the cadence that suits you best, with the goal of deploying as early as possible to production. And with more frequent releases, you're able to verify any problems that may arise earlier on. If you want to go even farther, continuous deployment gives you that possibility. In this case, when a change passes every stage that you've defined, the product the production pipeline is released straight to the customer. So it takes out that middle step of clicking a button after a pipeline has passed, and only when there is a failure that'll prevent deployment to production or straight to production. This is the most extreme way to speed up the feedback loop from a customer as work goes live within minutes. I'm not going to be doing a lot of this presentation around diving deep into CI and deep into like what continuous integration is, like around the theory of that. There's a lot of amazing videos out there that can talk more on how organizations can adapt this and go about implementing CI/CD just as a whole, separate from tooling. But what I'm going to do today is just go over how GitLab can help you do this. And so I'm going to, oops, there we go, start getting more into specifics around GitLab. So what we often see when CI/CD is implemented, we start to see that there's more low-risk releases. We have faster time to market. We start to see a lot higher quality in our applications that we're building. In turn, that's reducing our costs, so lowering cost. We start to see our product become a better product, and that results in happier teams, happier dev teams that are getting more time to spend on development than time spent on fixing. It's a nice little image here from GitLab, from our website. So we're going to start shifting over into GitLab here and CI/CD with GitLab. So here to talk about how you can implement CI/CD and going beyond just using GitLab as a source code management tool. So at a high level, GitLab's going to be allowing you to build your application using GitLab runners, run unit and integrates tests to check if your code is valid, package your applications and dependencies, manage containers, build artifacts. You'll be able to look at a live preview of your dev branch with review apps right before you send that out to production. You're going to be able to deploy to multiple environments like staging, production. You'll get advanced features such as canary deployments. Farther down, you're going to have capabilities around monitoring performances and status of your application, as well as incorporating security earlier into development. GitLab Runner is kind of a little bit of a history around that, but GitLab Runner is an open source project that is used to run your jobs and send results back to GitLab. This is .com. It is used in conjunction with GitLab CI, open source continuous integration service included with GitLab.com that coordinates the jobs. GitLab Runner is written in Go and can be run as a single binary. No language specific requirements are needed. It's designed to run on Linux, Mac OS, Windows operating systems. Other operating systems will probably work as long as you can compile a Go binary on them. And what can a runner be? A runner could be shader specific, tagged or untagged, protected, non-protected. What does that mean? That means shared runners are useful for jobs that have similar requirements between multiple projects. Rather than having multiple runners idling for many projects, you can have a single or a small number of runners that handle multiple projects. Specific runners are useful for jobs that have special requirements or for projects with a specific demand. If a job has certain requirements, you can set up the specific runner with this in mind, while not having to do this for all runners. So you can set up a runner to be able to run all the different types of jobs that it may encounter on the projects it's shared over. However, this could be problematic for large amounts of projects if it wasn't for tags. So by tagging a runner for those types of jobs it can handle, you can make sure runners will only run the jobs they are equipped to run. So for instance, at GitLab, we have runners tagged with Rails if they continue the appropriate dependencies to run Rails test suites. Additionally, you can protect runners from revealing sensitive information. Whenever a runner is protected, the runner picks only jobs created on protected branches or protected tags and ignores other jobs. GitLab Runner can be installed and used on Linux, Mac OS, FreeBSD, Windows. You can install it using Docker, download the binary manually, or use the repository for RPM deb packages that GitLab offers. You can see Kubernetes here as well. It's a very big part we'll see inside the demo around how you can get your runner going on a Kubernetes cluster. As a side note, I'd like to mention this, the GitLab runner version should be in sync with the GitLab version. So while old runners may still work with newer GitLab versions and vice versa, in some cases, features may not be available or work properly if there's a version difference. We only allow backward incompatibility for major version updates. The executors support different platforms and methodologies for building a project. To find out the key facts for each executor and decide which executor to use, just encourage you to head over to GitLab documentation. Great information there. We can find more on Shell, Docker, Docker Machine, Kubernetes, and maybe some lesser common used executors, which are VirtualBox, Parallels, SSH. So want to make the slides not too long. I'm going to go ahead and jump into a demo here and then get started on that. So here we're at GitLab. So GitLab CI it's an integrated, it's scalable, it's flexible, and it's a self-service tool. It's easy to set up, maintain, and it requires little intervention from an admin and in order to perform those tasks that you need for your project. When I look at GitLab, I say GitLab is made up of two main parts. The GitLab CI YAML file, which is considered to be the brains, and the GitLab runner, which is the body. What I'm going to do is start with the GitLab CI YAML file. This is the pipeline definition file, which specifies the stages, jobs, and actions that we want to perform. As you can see, this file is checked into our repository, which provides a number of benefits. The file is version, which means pipeline changes can be tested in branches, supporting any changes into your app code. Similarly, if you need to go back to an old version, the associated pipeline will be exactly how you left it for that particular release. And because it's under version control, it's easy to diff the file between versions for easy troubleshooting. That also means that there are a large number of ways to work with this file. So nearly all IDEs have direct integration with Git, if not GitLab. So you can use your favorite editor. Classic command line, of course, is always possible, as well as our integrated GitLab built-in web-based editor that you can see here. And you can also see that right here as well. Let's take a closer look at this file, and we can see how we could define the pipeline and integrate that with a wide variety of tools. one sec here. I gotta see how to. Okay. I can't share. I'm trying to hide something. It's not working. All right. So at the top here, oh, there we go. Zoom in a little bit. At the top of the file, we have a few defined global defaults, a Docker image to run our commands within. In this case, the official Maven image. Now in this pipeline file, you'll see that I'll probably use a lot of containers. This doesn't mean that GitLab CI is restricted to just using containerization. We'll talk a little bit more about the GitLab runner in a bit, but the runner can be installed on a bare metal machine or VM. Just think that containerization makes things a lot easier for folks in many cases. You can see that we have a few environment variables. We have some cache settings, which allow folders to be persisted between jobs to increase our performance. And next, what we're going to start doing is defining our stages and jobs. In GitLab CI, a pipeline is made up of a series of stages. Each stage then contains one or more jobs. So there are no limitations on how many jobs a single stage can have. And so we see with the stages, how the stages keyword is going to define the order the stages should execute in, regardless of the order that you, define on the individual jobs. So in this case, our flow is going to be build, test, generate docs, deploy, and trigger. When we start to define our jobs or the actions that we want to perform, our first job is to build our library, which we utilize Maven for. You can see here, we simply invoke Maven as we would as if we were running in our own machine. That is because the script you see here is actually just a bash script. This provides a great amount of flexibility because you can now automate anything you normally would do on your machine. After we build our library, we're now going to test it. So our test stage includes, and this is, again, this is just a demo, so you may have more complex or build it more, have more complexity to the different stages and jobs that you have within these, but for demo purposes, it's a simple couple simple steps. So test stage includes two jobs, unit tests and static analysis with code climate. And we're going to leverage Maven again to run our first test, but we'll also include Jacoco to generate code coverage reports. When the output, the coverage, so then the output, we then are going to output the coverage percentage into the build log. And the last step in this job is to take our code coverage reports and persist them with GitLab's integrated artifact repository. So the result can be used by other jobs or downloaded through the browser directly. We do this by simply just specifying the folders that we want to save. While this is happening, we will also be running a static analysis with code climate. Here we override the default image to utilize the official Docker image. Right here. And so we use that then to run Docker and Docker to execute the code climate image to analyze our source. Once that is done, we retrieve our JSON and persist it as an artifact. In the doc stage, just simply generating our Java docs, again, retaining them as an artifact. So now that we've tested our library, we are able to release it. We are going to use Maven again to publish our library out to the package cloud server. Now, if you're paying close attention, hopefully you are, you'll see that we are using a variable we did not define above. That is because this is a credential token which should not be checked into the repository. Instead, we add this as a protected variable in our project settings, which admins or only administrators can view. I'm going to take a drink of water. So as an admin, I can go over to my settings, CI/CD. I'm not going to open that tab. I'll just go to variables. And we can see that we have a package, that package cloud token here. It's hidden by default, and if I want to reveal that, I can reveal that. If I want to make it protected, I could do so. If I want to choose a specific environment, I can do that here. Head back. Next, our pages job. This is slightly unique in that this is a special job that works in tandem with GitLab Pages, which is our static site hosting feature. With Pages, deploying a static site is really as easy as creating an artifact. It's we do that here by specifying that we will utilize the artifacts of our two jobs, unit tests and Java docs. This job then copies those into a single directory structure, and it persists it as an artifact. So GitLab Pages will then take this and deploy out to the integrated hosting service, providing an easy, very easy and automated way of posting, and in our case, our code coverage and documentation. See that here. Not the prettiest UI, but it's still doing what we need it to do. When we see code coverage, you can see that being done here. Finally, we have our last stage trigger. For this last job, our Java app is made up of two components. This library and a front-end service, which used it, which is another project. And at this point, what we've done is we've confirmed. So actually, at the trigger stage, at the trigger point, we've confirmed that all of our tests passed prior to this, which is great start. But now, what about downstream projects that are utilizing this? And this job kicks that off to what we refer to as a cross-project pipeline. And so we take a stock Alpine image, install curl, then use it to trigger the API webhook for to start a new front-end service pipeline in the other project. Confirming that downstream projects are not negatively affected by upstream changes, and it's pretty simple. It's very just easy as a few lines of YAML to do that. I know, like, we have a certain amount of time here, and I'm running through this stuff, and obviously, always after the webinar's done, I'm more than happy to follow up. But just pace I'm keeping, just want to make sure we get all the information out to you as much as possible about CI/CD and the 50 minutes we have allotted. So when you know, as you can see, like this supports our larger goals of GitLab. So it's supporting the scalability, it's supporting flexibility, it's supporting self-service, and so a developer, they can integrate with any tool that they need. Just a couple examples that we have this YAML file without having to worry about installing plugins or involving administrators. And in most cases, they can simply provide the required container or VM to run the script in, or install their own runner on a bare metal machine with associated requirements. Integrating with static analysis and unit test frameworks is just a few lines of code. We also have a collection of templates which can be used to help users get started. And I'm going to show you that over in the repository. So if I were going to create a new file, as soon as I just get the .gitlab CI YAML, which is already pre-populated here, you'll see that I have some templates that pop up here and give me a drop-down menu. And this makes things easier and faster just as a jumping off point for a lot of users. Templates are in almost most languages, and I could choose whatever I'd like. I'll just maybe working on some mobile app or specifically focus on Android. Once I click on that, it's going to give me some variables and some basic tests that we can write off the bat. And you can customize this, add to it, take away from it as much as you'd like. So now what I want to do is I want to take a look at a previously ran pipeline for the YAML file that we just walked through. And so we'll dive in here, and this is a graphical view of our pipeline. I'm going to jump into the unit test and look at the build log as it was executed by a runner. And you will go too far over. We could see here how Maven is executing, and finally how our tests have passed. So the artifact from that is displayed in the output of the test itself, and we have a way to both download and browse our job artifacts. Over here is our code coverage, be able to download and browse those job artifacts. And additionally, these could be accessed in the future by our other jobs as we've seen through our pages functionality. All that right there, easily accessible. Let's go over to, actually, there it is, missed it. One second. Oh, I was on the wrong one. Apologize, got those mixed up. This was that was a code climate I was looking at. I'm just scrolling too fast there. So in the code climate, I've done this too much that I wasn't looking at it, but in our code climate image, we could see too many demos going here. So in our code climate, we could see that the code climate image was executed. It's executed within Docker within Docker. So then we collect the output from that job, and again, that's persisted as an artifact, which is also available as downloading or browsing here on the side, on the right side. But what I want to do is hop into our deploy stage, and then hop into our deploy job, and now be able to see that. Let's go up here, zoom in, and see that we were able to publish our library to our package cloud server utilizing Maven. So if you remember earlier that we utilized a protected variable, and with that protected variable, this was to ensure that the secure token was not committed to the repository. And we could see right here where I highlighted that it's referencing the variable without actually displaying the token in the log itself. So now our library is available for others to consume. If I jump into the pages job, it's just running these bash commands, putting all the files that we want to save in a unified folder. Again, and that's repetitive, but persisting those artifacts, that is our pages functionality, and then it displays those as that static website that I just showed earlier right here. So this is what this page's job is doing, giving us this information around code quality or docs or code coverage. Oop, too far. Something to know about GitLab is that, so GitLab provides a number of ways for notifications. Either if it's successful or unsuccessful run, you can get it in browser notifications. If you have Mattermost or Slack set up, you can integrate that with GitLab and get notifications via those two. Or you can receive email notifications on passed or failed pipelines, probably failed pipelines more often than not. Top right here, you can see the favicon showing that it's a passed. If it's failed, you'd have a red X showing as well. Going back to our pipeline view, we could see now how our cross-project pipeline worked for our front-end service. So we see all these green check marks, which is great. And then our trigger, which fires off our downstream pipeline. And then what we're able to do is if I go over here to this other project, demo app, I can go into that pipeline, which I did here, see that this pipeline was triggered from our upstream project and that our build, test, package, deploy, and run stages all completed successfully. Showing that our upstream changes didn't affect our downstream product maliciously. Obviously, this kind of cross-project pipeline trigger is great if you're having a microservice project that has multiple projects that makes up a larger project itself. Additionally, GitLab has a built-in container registry. So if you have any custom images that you want to store in GitLab, either for better performance or you just don't want them displayed on Docker Hub, you can store those all within GitLab. We do have one container here, and when I click into it, I can either manually prune these if I want, and of course, like GitLab does everywhere, there's instructions on using our built-in container registry on here as well. Pipelines. So that is that's a CI pipeline with a few lines of YAML. We've basically accomplished an integration with Maven. We've with our unit tests, our code coverage, and code climate. We generated some documentation. We published our library to package cloud. We generated some. We published the latest documentation to our pages website. Triggered a downstream project pipeline to ensure that there are no negative impacts, and we can do all of that without involving a single administrator opening up a ticket. This was completely self-service by me, the developer, with no plugins needed. Now, at the beginning of this demo, I mentioned that there are two parts to GitLab CI/CD, and we spent a lot of this time here looking at the CI YAML file. And so take a quick look, or take a look over at the GitLab runner, and we'll talk about, take a few minutes basically to talk about how this is an important part of GitLab CI/CD. GitLab runner is it's a small portable app, which we build for a wide variety of platforms. It's the worker bee. It picks up and executes the jobs that we specified in our pipelines. In the CI/CD settings here, this is where a developer can take a look at the runner configuration for their project. So you'll see that we have, as we talked about earlier, two categories of runners, shared and specific. Shared runners are shared runners are runners that have been provided by administration of the GitLab instance. So we've been using several, or one here, a couple different shell runners, as you can see. And what this does is, by allowing administrators to provide a shared pool, there are a number of benefits, and those could be consolidation of infrastructure, whether it's cloud or on-premise. Clusters and credentials can be centrally managed. It can reduce efforts required to set up CI for each team. But there are some cases where an administrator has maybe not provided a shared pool, or they don't meet your needs. And for these cases, we have the ability for any dev team to connect their own runners. They simply download the runner, enter the URL and key, and you're on your way. And I mean, to show how simple that is, I'll just show the process real quick here. But in the interest of time, I did install the GitLab runner. So if I were, I gotta get this thing out of my way. There we go. I just do this real quick. So just GitLab runner register. It's going to ask for the URL. Everything's provided here. I can simply copy that in there, paste it, and then same thing with the token. Not too much difficulty around this. Give it a description. And then it's going to ask, is there any tags that we want to specify? So like talked about, tags allow you to uniquely identify runners with certain properties. Maybe in this case, going off of we're working on mobile applications, and I'm working on iOS. I don't want this runner to be specific to iOS. I'm just going to give it that tag, identify specifically what I've installed with that tag. And that could be specified in the GitLab CI YAML file that we went through for the job that we want to run. Last choice, what we have is is what mode of operation we want for a runner. So simplest is shell, executes the script on the machine and account it's installed on. But we then have support for working with images and containers via VirtualBox, Parallels, of course, Docker, and Kubernetes. The runner will start the specified image, execute the job, and then clean up. These modes are great for shared runners because the development team can bring their own base image to start from. Last mode of operation is what we call our auto-scaling runner. We support this on Docker machine and Kubernetes. And here, this is when the runner will elastically process jobs as needed to process the CI queue. I'm just going to do shell. Quick example. All right, registered successfully, and refresh the page. Click on runners, and there we have it. And my runner off and ready to go. In that case, pretty simple, but it'll take a little bit of time here. I got two of them. Uh-oh, I deleted the other one earlier. Someone else's. It's going to do a couple minutes of back and forth, and then it's going to have a green. That's because I did it in this project. And it'll have a green available, ready to go. I'm not going to do building anything out, but I did want to talk on canary deployments. I don't have it set up for this demo, but talking about canary deployments, when people are looking to embrace continuous delivery, company often needs to decide what type of deployment strategy to use. One of the more popular strategies is canary deployments, where a small portion of the fleet is updated to the newest version first. This subset then can serve as a proverbial canary in the coal mine. And if there's a problem with a new version of the application, only a small percentage of those users are affected, and the change can either be fixed or quickly reverted. So if you're leveraging maybe a Kubernetes canary deployments, you can visualize your canary deployments right inside the deploy board. The deploy board. I need to take a drink of water. And you don't even have to leave GitLab to do that. And I just want to show, this is a different demo, but only showing one here, but a nice image to show that. In our the deploy board is here, and we can see several different instances that have been set up. So canary deployments can be used, when you want to ship features to only a portion of the pod's fleet and watch the behavior as a percentage of your user base visits the temporarily deployed feature. If all works well, you can deploy the feature to production, knowing that it won't cause any problems. Canary deployments, a lot of times they're very, very useful just for like back-end refactors or performance improvements, maybe other changes where the user interface doesn't change, but you want to make sure performance stays the same or improves. So this is the ability of GitLab CI. It's to allow development teams to set up their own CI/CD infrastructure. It's very, very transformative. A couple points is around. First is self-service. Instead of needing to file a request for a new piece of hardware, wait for the response, justify the changes, costs, and have a PO potentially filed, dev team takes 2 minutes with an old machine maybe from the cabinet, and off they go. Dev team is happy and more productive. Infrastructure team is happy. They don't have to worry about managing maybe a flock of Mac Minis for iOS team in their data center. It's going to provide a lot of flexibility. So if you need to run jobs on a ARM device, perhaps or Android or deep learning, it's easy as installing just the runner on Android. Need to run something like on a mainframe like Linux on Z, just build the runner, away you go. If we don't support any operating systems, the SSH executor that can you can log in and run bash commands. So managing hardware and software dependencies when something like a container is not possible, it's pretty easy. Scalability, with a handful of auto scaling runners on GitLab.com, they're routinely processing over 1,000 concurrent, 1,500 or more CI jobs, and if more are needed, just simply turn up the dial. So GitLab, CI/CD, and there's a lot to GitLab. We have to try to shove a lot of it in this time frame. There's more that we're hoping to keep doing more webinars, more technical deep dive and specific webinars or just videos that we'll post out to YouTube. But GitLab CI, it's very, very flexible. If you can bash it, you can automate it in the YAML file. You have self-service runners and no external plugins to manage and maintain. You don't have a brittle configuration, and you have SaaS scaled CI with auto scaling runners if you want those available to you. All right, where are we at? So got about 5 minutes left. Cut out of this, go to this. And open up for Q&A. One second here. Itzig has been on top of this. Itzig, feel free. Yeah, you've been answering the questions. Itzig is, he's been inside the chat answering questions. Itzig is our CI expert. So looks like he's been knocking these out. There you go. All right. Couple. Itzig, you're on there? Nope, don't want that. Itzig, oh, you have to come off mute if you want. Maybe not. Give me 1 second here. Agnes.
How can I help? I saw Ipsic has been helping with the Q&A at the chat. William is also on the call, helping stand by for the Q&A. Thank you so much for the awesome presentation, Tye.
No problem. So I guess I'm trying to do the Q&A here, but looks like Itzig's been.
Would you like me to read some of the questions?
No, that's okay. I have a couple here. I mean, there's a couple questions that I got earlier on. Version of Docker, do I need to install for GitLab Runner? I think that's at least 1.5.0. Logs stored when run as a service. If the GitLab Runner is a service on Linux, the logs are they'll go syslog, and then if GitLab Runner is a service on Windows, it's going to be logs to systems event log. So I'll get that. What I could do here, I see Itzig has answered a lot of questions. We'll take all these questions and try to get answers out. Can we do that, Agnes? I guess I've never done this. Can we answer people after the webinar? Agnes, question for you.
Sorry. Yeah, so we definitely can do that. I think whatever question we can probably answer like one or two, and then if we don't cover everything, then we can definitely send it out via, directly to the after.
Okay.
But yeah, I think if, William or it's like, if you want to, answer some of these via text as well, to help with basically tackling it live, we can do so right now. And then, Tye, if you want to take one or two, maybe to just answer live.
All right.
Or do you think that would take too long?
Well, I mean, we have a few minutes here. Runner on AWS, you could do that. You could do that via variables. Some of these are very specific questions that we'll have to follow up with too. So here's another one. You say that GitLab CI/CD can completely replace Jenkins as a complete solution. Our answer at GitLab is yes. You have a tool that you have the capability of having your source code and your CI/CD in one spot. It's in one application, so you're able to have that just right at your fingertips. So you don't have to have a Jenkins to GitHub with a Docker, maybe like a YAML file inside of GitHub, and that's being called out to Jenkins, and then you're kicking off your Kubernetes that way. You could do that all inside of GitLab, and even more outside of just what is SCM and CI/CD. You have project management piece to it, so you can have what we'd call as a replacement of Jira, and that's your starting point, and then that's tied to that repo. Merge requests are being built out of the issues that are developed, and then you have the capabilities with GitLab as well of incorporating security, monitoring, and performance. So I would say yes. I mean, we at GitLab think that we can be a direct replacement for Jenkins, and you won't have that need. And I encourage you, if you have Jenkins right now, just start off and GitLab, doing your CI/CD, and build it out that way. Good feedback here around more Canary deployment. So we'll do some specific stuff around that. Yeah, a lot of great questions. We'll see. Oh, it's doing this.
Yeah, Tye, this is William just chiming in on a few. I saw some of the comments in chat about our advanced deployment strategies, such as Canary deployment and incremental rollout. And the question sounds like, do you need to have Kubernetes set up in order to use those advanced deployment strategies? And the answer is yes. You can, in order to use the GitLab built-in Canary deployments. Now, as you saw, Tye did the demo, GitLab CI/CD is very, very flexible, and anything you can script, you can run in a runner. And so if you were to build out your own Canary logic, you could certainly do that with GitLab CI/CD on any type of deployment environment. However, GitLab has really nice built-in incremental rollout and built-in Canary deployments. That's just a configuration setting, and that works when you use the Kubernetes integration.
Sweet. And I think we probably need to do a webinar on Canary deployment based on some of the feedback here. Agnes, with that, I mean, we're at the 50-minute mark. So what I'll do is, I mean, there's a lot of questions, specific questions. We'll get these and get responses to them, and then build out that dialogue for any other questions you have after those are answered. Does that work, Agnes? I'll let you wrap it up, actually. And the big question we'll always have is this: when this will be available? Where will it be available for consumption?
Okay. Yes. Yeah. We can definitely wrap it up, and then we'll have basically the Tye or PMM reach out to you directly to answer some of these questions, just because we have so many really good ones come in. So yeah, so thank you again for joining today's webinar. We've attached some resources here, as well as if you're interested to get started, feel free to download our free trial and check out GitLab end-to-end built-in CI/CD. So thanks again, Tye. Thanks, Itzik. Thanks, William. And we'll send over the recording. Thank you.
Thank you all.